Welcome to EDU World Space.
Question, we have this situation. At this instance shown, A throws a ball, throws a football with an initial speed of 20 meters per second, 60 degrees from the horizontal. So ball C undergoes projectile motion. Okay, and then
Here's a clean and professionally formatted presentation of the calculation shown in the image.
Thrown, B starts to run forward. We need to find the
Application
speed of
of
B
the
in
work
order
energy
for B to
theorem,
catch the
WET.
ball
From the work energy theorem,
successfully.
the force
And we also
F is
need to
given
find the
by F
velocity of
equals
C
frac text
relative to
KE,
B at the
where
instant of
KE
catch, as well as
equals
the
kinetic energy,
acceleration of C
S
relative
equals
to
stopping
B at the
distance.
instance of
If I'm
catch.
given for object
Okay,
A,
so to
FA
do
equals
this,
frac 100,000,
first we
0.10.
need to
For object B, FB equals frac 225, 1500
recognize
equals
that the
0.15
football
text
is
makes. And force
doing
ratio frac
projectile
FA,
motion.
FB
So
equal
we
frac
can find the time of flight.
0.10, equal
Okay,
fractional result.
that's the
I'm
time
a
of
box
flight
frac FA, FB. Would you like a PDF version of this explanation?
of C RBT. Okay, so we have we'll be using V naught Vy is equal to Vy naught plus Ayt. Okay, and taking downward to be positive. So so we look at the ball. So this is the projectile. Okay, this is the initial, and then this is the final. Okay. Right. So this is the final. Then the data are the same. In this case, 60 degrees. So the final y component, the y components of the final velocity will be v sine theta, and then the initial, the y components of the initial velocity is negative v sine theta, and then plus gt. Okay, so we can find t to be 2v sine theta over g. So 2 times 6, 20 times sine 60 degrees divided by 9.8. And we calculate this t, it is 3.53 seconds. Okay, and then the horizontal distance, the range of C will be V naught cosine theta times t. So putting in the numbers, 20 cosine 60 degrees times 3.53 seconds. Calculate this, you get 35.3 meters. Okay, so okay, so this is A, this is B, and then this is the range of the football, 35.3. This is the distance, initial distance between A and B. Okay, so the distance, so the speed of B required, okay, will be the distance divided by time. The distance will be 35.3 minus 15. The time will be 3.53 seconds. Calculate this, you get 5.76 meters per second. Okay, so this is the answer for the first question. Okay, next we want to find the relative velocity of the football relative to B. The velocity of football relative to B at the instance of catch. So at the instance of catch, okay, to find the relative velocity, we need to first write down the velocities in vector form. So VB is going to be 5.76 I hat meters per second. VC will be 20. cosine 60 degrees I hat minus sine 60 degrees j hat. Okay, and this is 10 I hat minus root 3 j hat meters per second. So the velocity of the football relative to B will be 10 minus 5.76 I hat minus 10 root 3 j hat. Calculate the terms out, you get 4.24 I hat minus 17.3 j hat meters per second. Okay, and we can find the magnitude of the relative velocity. So you square the components and you sum them up, and then you take the square root. Okay, this is 17.8 meters per second, and then the direction would be arctangent. The y component is 17.3 divided by the x component 4.24, and you calculate this, you get 76.2 degrees. Okay, so so this is how the relative velocity vector looks like. Okay, so velocity of C relative to B. Okay, this is 76.2 degrees. Okay, so magnitude of the relative velocity and the direction. Okay, next we move on to the acceleration. So acceleration of B is 0 because B is moving at constant speed. Okay, the acceleration of C is negative 9.8 j hat meters per second square. So the acceleration of C relative to B is negative is acceleration of C minus acceleration of B. Okay, so you get negative 9.8 j hat meters per second square. Okay, so this is the answer for the relative acceleration. Okay, and that's all.